Welcome students. In this video, we're going to talk about limits at infinity. Specifically, we're going to talk about rational limits at infinity at rational functions. So we said that the limit as x approaches infinity of x squared plus 2 over x cubed minus 1. So we're going to do a little work first. So the way we're going to do this one is we're going to divide by the highest degree term. So in this case it's x cubed. So the way we do it is like this. We divide by everywhere by x cubed. Now we simplify this rational function. So this we're gonna be left with 1 over x plus 2 over x cubed. Then x over x cubed over x cubed, that's 1 minus 1 over x cubed. Now this one becomes limit as x approaches infinity of whatever we found here. So now we take the limiters of each term. That's gonna 1 over x, that's 0, plus x cubed becomes 2 over x cubed becomes 0. Limit of 1 becomes 1, and this term becomes 0. So we're left with 0 over 1, which is just 0. So that's the first answer, 0. Now let's look at another similar example. Limit as x approaches infinity of x squared plus 2 over x squared minus 1. Notice on the previous one we got 0. On here we have the highest degrees in both numerator and denominator. So let's see what happens. So let's do our scratch work. So x squared over x squared plus 2 over x squared all over x squared minus 1 over x squared. That becomes 1 plus 2 over x squared all over 1 minus 1 over x squared. Now we take the limit as x approaches infinity of the term that we found. So that becomes like this. Now we take the limit of each term, so that would be limit of 1 is 1. This term here as x approaches infinity becomes 0. That becomes 1, and this becomes 0. So the final answer is going to be 1 over 1, which is just 1. And that's the final answer for this example. Let's look at another similar example where the limit does not exist. Limit as x over x squared plus 2 over x minus 1. Notice here that the highest degree is in the numerator. So we're going to get something. So this is equal to infinity, or limit does not exist. And we're going to see why. So whenever we have numerator higher degree over denominator, that's what we get. So let's see what was going to happen. Okay, so limit. So let's do the little scratch work. So x squared over x squared plus 2 over x squared over x squared minus 1 over x squared. So this becomes 1 plus 2 over x squared. This becomes 1 over x minus 1 over x squared. Now we take the limit of what we just found. So now we take the limit of each term. That will be 1. This becomes 0. This becomes 0. And this becomes 0. So we have 1 over 0. Well, the 1 over 0, that's the same thing as infinity, or limit does not exist. And that's the final answer. So notice, sometimes we have when the limit as x approaches infinity becomes 0, a number, or when it does not exist. So those could be the 3 cases for a rational function. Thank you very much, students.